So today we're doing a QC check on a pre-existing installation. That's going to involve checking the condition of the solar panels on the roof, the cable, the isolators, the connections inside. We'll look at the inverter, how much it's been generating, what the current generation is today compared to the light levels outside, and so we can give an overall report of what they need to improve, if anything. Yeah, we're going to have a look now and see what the voltage is on each string.
So what voltage is on each string?
So on this string you've got 330, on the other one it's 189, and what we want to do is compare that to the number of panels that are on the roof. That'll just give us an idea if all the panels are working properly. There's other tests we'll carry out as well, but it's just a bit of easy information that we can get from the machine. So the machine's currently making 40 watts, 30 watts now, in this very overcast December weather, and the total energy it's ever made 7,356 kilowatt hours, which we can compare to the data when it was installed and the installer's projections, just to see how well that's worked out. So now I'll just do some tests by basically checking what happens when you turn off the isolators and do the strings disconnect.
And what are you looking out for when you turn off these isolators?
So I'm just turning the isolators on and off just to see if the DC voltage does turn off, which in this case it doesn't seem to, so I'm not sure what's going on there. DC 1, if you turn it off, the voltage drops straight away. On DC 2, when we turn it off, it seems to sit there reasonably happily, so that's a bit of a cause for concern. And then I'm going to turn off the AC supply, and hopefully the whole system should then automatically shut down as if it was a grid failure. Okay, so it's registered there's a power loss, but just this one I've got a cause for concern for already, just from the readings on the machine. But yeah, we'll be really thorough. We'll go through, we'll be looking for cable entries, have they been sealed to keep out wind and moisture, every other connection, how the cables run, again another cable penetration with no not being made good afterwards, and we'll check all of the connections even in the meter, just to make sure there's no issues whatsoever. So we're now looking at the AC supply to the inverter, checking that all the connections are tight, that they're in the right positions, and the connections to the meter. And already some of the things that have stood out is that the armoured cable is only loosely connected into the isolator, and it's missing its fly lead, although there might be one at the other end. And then a couple of the connections in the meter were a little bit loose, or had the heads chewed on the screws. So I've just checked the ZS and ZN readings from the supply, and they look reasonable. We'll go and compare the size of the circuit breaker to the size of the rating on the isolation switch in a minute, but again a little bit suspicious it might be too small at only 20 amps. Okay, so we're now going to have a look at DC Isolator 2, just because that gave the slightly surprising readings. When I turned it off on the machine, it didn't register straight away that the DC voltage had disconnected. So I've disconnected the MC4 connectors from the bottom of the inverter. The DC isolator is off, so the string's turned off, and I'm going to connect these MC4 cables into my adapter that allows me to measure the DC voltage more safely without any risk of touching any live parts. Registering 250 volts from string DC2, and when I turn the DC isolator off, with a bit of luck, oh good, it has turned off. So I think within the machine it was just a delay on registering that it was turned off. So it does look like the DC isolator is working. Okay, so the next thing we're going to do is use the current clamp and the adapter to check what the short circuit current is of this particular string. And it's currently got 5.85 amps. And so now we'll go outside and test the light intensity and then compare the values. So we've just taken this reading on the roof next to the panels at the same angle, and we've got a reading of about 3000 lux, and we'll now use this value to compare to the value of the current that's coming off the string. So I'm now going to test the insulation resistance between the positive and negative of the panel string and the earth of the supply to check if there's any leakage. So we've got positive and negative going into the adapter I'll turn them out, which short circuits them, and then testing between short circuited positive and negative and the earth of the supply. Okay, and it's saying there is some residual voltage and about 10 mega ohms of resistance. So having had a look at the roof and the metal frame of the roof and the metal panels, I think there would be a benefit to bonding the panels and the array to the main earth terminal. We finished our inspection and testing of the DC equipment. We're now going to go downstairs to have a look at the AC plant room.
A few moments later.
So here we are at the AC supply of the client's AC setup, and already there's a few standing out features such as open holes, IP fails on the top, missing fly lead on the steel wire armour to upstairs. And as we open the distribution board, the cover it's not properly attached and it's using wood screws, and also there's a lot of holes and spaces in it. Looks like our solar's fed from a B16, so the 20 amp isolator upstairs isn't a problem, but I think there's going to be a number of issues for the client to address here. Unfortunately, there's also a lot of advice on remedial work that I think needs doing, but that's how it is. If you like this sort of content, don't forget to like and share, and also subscribe.